Hi there, welcome to this Elkchemist chemistry practical video. This is going to be a kitchen chemistry video, one you can do in the comfort of your own home. This is the magic milk experiment. And the first thing you're going to need is a shallow dish of milk. That needs to be full fat milk if you're in the US or whole milk if you're in the UK. Now the next thing we're going to need is an assortment of different coloured food dyes we're going to add into the milk in just a second. And the final thing you're going to need is some washing up liquid or washing up detergent and a couple of cotton buds to dip into the washing up liquid and then into the milk to allow the experiment to actually work properly. So now you have all the apparatus you're going to need to do the magic milk experiment, and next thing to do is to add some food dye into the center of your dish of milk, like so. It may not look like much now, but all we're going to do is dip the end of our cotton bud into the detergent, really soak the detergent onto the end of the cotton wool bud. Now, just watch what happens when we dip that detergent into the center of the mass of dye in the middle of our milk. Here we go. How cool is that? Look at that dye spreading everywhere. Isn't that amazing? Look at those patterns. Look at the dispersion. It just keeps going. And the great thing is I can then start moving that detergent to different areas and starting some new ripples going in those areas as I move around. And the question is, why is this happening? Now I'm going to repeat the experiment one more time and explain where these eddy currents are coming from and what is causing them, to really explain exactly how the milk works, but also how the detergent works to create the magic milk experiment itself. I think you agree, rather a cool effect. Let's start off by talking about milk in more detail. Now, milk is a much more interesting substance than might initially seem. Milk is known as a colloid. Colloids are two-phase systems, and most colloids can be defined as a mixture in which small insoluble particles are spread throughout a larger volume of a liquid. But unlike a suspension, like say for example chalk in water, the colloids are stable systems and the particles won't settle out if left. That's why milk looks the way it does. Now, milk is a specific type of colloid known as an emulsion. An emulsion is a mixture of two liquid phases which are usually immiscible, i.e. they don't mix, but have become mixed in a very stable manner to make a colloid known as an emulsion. So milk is not two separate layers. It is in fact a mixture of fat globules dispersed within a dispersal medium, i.e. the other liquid, which is mainly water. So in reality, milk kind of looks a bit like this. A mixture of polar water molecules, which have slightly positively charged and negatively charged regions known as delta positive and delta negative charges, uncharged fat globules, and proteins, which themselves will also have positively and negatively charged regions. The water molecules are going to be in the vast majority in terms of the population of molecules in the milk itself. Detergent molecules have two regions, a negatively charged or anionic head, which is hydrophilic in nature, water-loving, and we're attracted towards the delta positive regions of the water molecules, the hydrogen atoms in the water molecules. The other part of the detergent is the hydrophobic or fat-soluble tail, the water-hating part, which will interact better with the fat globules in the milk. So when we first add the detergent to the milk and to the dye, the detergent molecules rush towards the surrounding water molecules and the food dye runs out in every and all directions, a bit like this. Dipping in more detergent causes more motion, as some detergent is being attracted towards the positive regions of protein molecules in the remaining milk, due to the anionic head being attracted towards the positive charge on those proteins. Meanwhile, the hydrophobic or fat-loving and water-hating tails will be interacting better with the fat globules. And so you continue to get these eddy currents as molecules interact with each other until the whole thing becomes a real cacophony of mess. And that is the nature of how the magic milk experiment actually works. As always guys, thank you so much for watching, and if you enjoyed this video, please think about subscribing to the channel, liking the video. You can even ring the bell to keep notified about its content. You can even share this video or other videos on the channel with friends studying chemistry, and a bit more about how the subject works, and do some interesting little experiments like this one, for example. Lovely eddy currents coming out there, look at that. All it stands for me to say, guys, is thank you so much for watching. Take care. Bye now.